So we saw in the last video that a electrical current can induce a magnetic field around a current carrying wire. So wherever charge is moving, we make a magnetic field. So that sort of begs the question, well, what happens if I were to have a magnetic field? Could I make an electrical current, or could I cause charge to move? And this is what was Faraday's experiment. So he was the one who sort of came up with this idea and decided that he was going to test to see, can a magnet or a magnetic field, remember we're using the letter B for magnetic field, induce or cause a current in a wire, right? So I'm going to show you a simulation that actually demonstrates Faraday's experiment. So essentially what he did was he made a loop, right? And he hooked the loop up to, here it's hooked up to a light bulb, but he actually had it hooked up to this, which is called a galvanometer. It just pretty much measures voltage. And notice that right now the galvanometer is at 0, right? And so he thought, like, if I bring this magnet close to this loop, that'll make a magnetic field, and therefore what will end up happening is that there will be a current in the loop. So he brought it close, and as he brought it close, he saw it jump, right? So see how the arrow's jumping? I'll demonstrate with the light bulb here in a second. But once he got the magnet close, and then it stopped, right? Let's look at it with the light bulb so you can see. So the magnetic field is there, the magnet's there, and then you move it, the light goes on, and then it stops. And then the light goes on, and then it stops. So essentially what he realized is a magnetic field itself does not induce a current in a wire, but a change in the magnetic field, which we call flux, is what will cause a current. So by moving this magnet and changing the magnetic field that the light bulb is experiencing, we can see that a current is induced on the wire. Now there's lots of different things that can affect the current. Some of the things are the number of loops here. So if I increase the number of loops, that will affect the amount of current. I also, if I change the loop area, that will affect the amount of current on the wire. See how it's really, really bright with the large area? Or if I affect the strength of the magnet. So for those of you who are mathy, let me kind of show you the equation for it. You're not going to have to use it, but it might make a little bit of sense. So we say that voltage, or the volts that are induced, is equal to N, which is number of loops in the coil, times the change in B, which could be the change in the magnetic field, or the change in area of the loops over time. This idea right here is also called flux. All right, so we can cause a current on a wire by changing the magnetic field, or changing the number of loops, or changing the area that the loops are experiencing. So after we've kind of developed this concept, in the next couple of videos I'm going to talk to you about how both transformers and generators work.